And on this next example, we are dividing powers that have the same base. So the x is there and then the y is there. Now notice I can't write it out the long way. I can't say x to the n power because I don't know how many x's I'm multiplying. I don't know what n is. So what I need to do is follow my rule that says if they have the same power, you keep the power the same, you subtract the numerator's exponent minus the denominator's exponent. So n minus 2 is nothing that I can simplify. I have to leave it like that. I'm going to go on to your next base. Your next base is y. The numerator exponent is 3n, and I'm going to subtract the denominator exponent, which is 4. And again, I can't combine those like terms, so that would be my final answer. Now, if we take anything to the 0 power, it's 1. If you don't believe me, plug it in your calculator. 4 raised to the 0 power is going to be 1. Okay, now anything to the negative power. What you can do is turn it positive if you put it in the denominator. Right? Or if it's already in the denominator, you can turn it positive and put it in the numerator. So right now, this is a to the negative m over 1. So what you have to do is end up flipping them. Put 1 in the numerator, a to the positive m in the denominator. Okay, so you can change a negative exponent positive if you move it to the opposite side of the fraction. And then let's say you have a fraction or division going on, a divided by b, and that entire fraction is raised to a negative power. You can turn it positive, remember, if you flip those. So now it's b over a to the positive m. So for example, 3 to the 0 is 1. Anything to the 0 is 1. 3 to the negative 2. Okay, so right now that's 3 over 1 to the negative 2. So what you're going to do is you're going to flip that, put the 3 in the bottom, change your exponent positive, and bring the 1 to the top. All right, so 1 over 3 squared would simplify to 1 over 9. Now I have a fraction raised to a negative exponent again. So if I flip them, put the 4 on the top and the 3 at the bottom, that exponent will turn positive. Okay, so anything to the first power is itself, so I get 4 over 3. All right, here's a helpful study tip that 0 to any negative number is always undefined. And then 0 to any positive number is going to equal 0. And then also 0 to the 0 power is also undefined. Okay, so also need to know that. Let's use some of these rules to rewrite expressions only using positive exponents. So 2 times x to the negative 1. Notice a and b are different from each other. This says 2x, the whole quantity to the negative 1. This is saying just the x to the negative 1. Okay, so because the x is the only thing that has the negative, that x goes in the denominator and that exponent changes positive. The 2 doesn't go in the denominator. He stays up top. Okay, he stays up top because that negative isn't on him. But over here, the entire quantity 2x goes to the denominator and you change the exponent positive. Well, what's left in the numerator? Well, remember this was over 1, so I need a 1 up there, just like there's a 1 in the denominator here, but I don't always have to write a 1 with my x, so that's why I didn't. All right, so this would be 2 over x, and this one would be 1 over 2 to the x. They looked similar, the only thing that was different was the parentheses. So make sure you understand the difference on when there's parentheses and when there's not, and what that means for your answer. Okay, on the next one, see, 3 over x to the negative 2. So we can't have any negative exponents, so what I need to do is bring that x to the top of my fraction and change its exponent positive. There's also a 3 up there. He can stay. He doesn't have a negative exponent on it. So what's left in my denominator is that 1 that was with the x. Okay, so it's like a placeholder. But I don't have to write divided by 1 because anything divided by 1 is itself. And over here I have 1 over 3x to the negative 2. So that entire quantity, that parentheses, means that the whole 3x needs to be brought up top, and you need to change the exponent positive. And it's times by 1, but That 1 up top I don't really need to write. And so what would be left in the denominator, again, is a 1. Don't need to write it. So 3x quantity squared would be my answer. Remember, this is a product to a power from part 1. It's like 3x times 3x, right? So I'm squaring the 3 and I'm squaring the x, which means that my final answer would be 9x squared. Okay, so 3x squared is equal to 9x squared. Notice I had 3 to the x squared here, and I had 3x quantity squared. That can't be simplified. This does not mean square the 3, but this one does. It means square both of them. So that's why I'm getting different answers here. My answer was 3 to the x squared, and this one was 9 to the x squared. E and F. Let's get rid of our negative exponent first. So that negative 3 is only on the x. It is not saying negative 5x to the negative third power. Okay, so in my parentheses, and outside my parentheses, there's a square. So let's just do inside my parentheses. In my parentheses, I have a negative 5. But this x, since it has a negative, I want to bring it to the basement, to the denominator, and change its exponent positive. The 5 gets to stay because, remember, the negative 3 isn't on the 5. So now let's simplify that a little bit more. Okay, I rewrote it using positive exponents, but let's just go ahead and follow our rule that says if I have a division and I'm squaring this division, I need to make sure my negative 5 gets squared, and I need to make sure my x to the third power gets squared. So negative 5 squared means negative 5 times negative 5, which would be 25. And I have x cubed squared, which would be x cubed times x cubed, remember? So I have 3x's being multiplied times another 3x's being multiplied. If you don't remember, a power 2 of the power rule means multiply that 3 and the 2 because there's going to end up being 6 x's. So 25 over x to the 6 would be my answer. Let's do F, part F, and take it step by step. So in my parentheses, I don't have any negative exponents, so we're good there. Outside of my parentheses, I do have a negative exponent. Now, if I follow my rule, I can change this exponent positive as long as I flip my fraction. So 7x needs to go on the bottom, and y squared would need to go into the top. Okay, now let's simplify some more. So y squared gets squared, and 7x gets squared. My negative's just hanging out in front. So I need to take y squared to the power of 2, which would be y to the 4th, and 7x to the power of 2, which would be 7 times 7, and x times x, so 49x squared. And I have that negative, like I said, out in front of my parentheses. It's being multiplied by a negative. Remember, 7 squared does not mean 14, it means 7 times 7. If you have any questions, please raise your hand and I will come around and explain it better in person. Okay, I have 3 more that I want to do. 12x squared y to the negative 4 over 6x to the negative 1 y squared. These are problems that you're going to see on WebAssign. So what I would suggest doing is simplifying your fractions first. 12 over 6 could simplify to 2 over 1. So I have a 2 in the top, a 1 in the bottom. I'm not going to write my 1. X squared can stay because he's positive, but y to the negative 4 can drop to the bottom and turn positive. X to the negative 1, I don't want negative, so I'm going to bring him to the top and turn him positive. And y squared can stay down there because he's positive. So now what do I have? I have an x squared times an x to the first, which means there's 2 x's being multiplied by another x. That means I have 3 x's being multiplied, so x cubed. 4 y's being multiplied by 2 more y's, which means I have y to the 6. Remember, we can add the exponents when we're multiplying powers with the same base. Multiplying this times this, they have the same y. I can add the 4 and the 2 to get 6. Or I can think about it the long way. Like I just said, 4 y's being multiplied times another 2 y's, y to the 6. H. I have a negative 3 exponent, so I first want to get rid of that negative 3 on the outside. And go ahead and flip these to make that 3 positive. The 8x to the negative 1 would go down, and the y to the 4th would be in the bottom. 4x to the 3rd would move up, y squared would move up. Okay, I still have negative exponents. So I need to work on getting rid of that negative 1. I'm also going to simplify my 4 and my 8 to be 1/2. And I don't technically need to write that 1. X cubed can stay up there. But this x to the negative 1 I'm going to bring to the top and change its exponent positive. Y squared can stay up there. And y to the 4th can stay down here because they're both positive exponents. And I still have my cubed on the outside. So let's combine some things. X to the 3rd times x to the 1st, that's x to the 4th. And let's go ahead and simplify my y squared and my y to the 4th. Okay, these 2 y's would cancel with 2 of those y's, right? Just like if I wrote it the long way, y times y over y to the 4th. 2 y's would cancel, and there's 2 left in the denominator. So I have x to the 4th in the top and 2y squared in the bottom. Now let's use our exponent of 3. He gets applied to the x to the 4th. So I have x to the 4th being cubed, and I have 2y squared being cubed. X to the 4th cubed. I have a power to a power, so the rule is that I can multiply the 4 and the 3 and get 12. If you don't remember that rule, write it the long way. X to the 4th cubed means 3x to the 4th. So 4, 4, and 4 makes 12. And in the denominator, I'm cubing my 2, which means 2 times 2 times 2, so 8. And I'm cubing y squared, so y squared times y squared times y squared. There's going to be 6 of them. Remember, you can power to a power, you can multiply the 2 and the 3. For a final answer, there's nothing else I can simplify. X to the 12th over 8y to the 6th power. And the last one. 3x times y to the 0 power over x squared times 5y to the 0 power. Remember, anything to the 0 power is going to be 1. So 3x y to the 0 would end up being 1. I don't really need to write times 1. And then 5y to the 0 power. Now this is all to the 0 power, so that would end up turning to 1. So I have 3x over x squared. And remember, my x's are going to end up canceling one of these x's with one of those x's. So I have a 3 in the top and 1x in the bottom. All right, that concludes 5.1.